of the nervous system.
Okay, tell me, what is it the only thing that you understand about HAFIZA?
From what I understand, this nervous system forms a complex collection of the nerve cells and fibers that transmit signal between different parts of our body. The nerve carry the message to the brain and back to the body so that the brain can interpret them and take the action. Other than that, the system is made up with brain, spinal cord, and all the nerves of our body. Oh yeah, another thing. The nervous system controls everything that we do, including the way we breathe, the way we walk, the way we think, the way we feel, and that's all. I don't really remember about CNS, PNS, what are those again? Peripheral. I only know about PMS.
Let me explain what CNS, which stands for Central Nervous System. Do you guys know why this nervous system is known as central? Take a guess. It is known as central because it provides a large number of functions compared to the other. CNS consists of two, which are the brain and spinal cord. This part is very crucial, which does the overall thinking about stimuli that the body receives from sensory receptors from something called PNS, I guess, and it processes the information which determine an appropriate response and pass the information to the part of our body through PNS. Oh, Ali, I believe you catch up with what Dr. Hisham said about the peripheral nervous system. Can you explain a little bit about it?
Yep, that is true, IZWAN. PNS stands for the peripheral nervous system. It is different from the CNS because it acts as the communication line between the CNS and the rest of our body. It includes the cranial nerves and also the spinal nerve. The peripheral nervous system can be divided into two divisions, which is the sensory division and also the motor division.
Does it involve the pathway of afferent and efferent neurons in our body?
Yes, it does. The afferent neurons control the sensory division of PNS. It is divided into two parts, which is the somatic sensory and the visceral sensory. Okay, the somatic sensory, it generally controls the pain, touch, temperature, and also proprioception of certain body parts. But they also have special functions to control hearing, equilibrium, and also vision. For the visceral sensory, it has special functions to control nerve fibers that are related to taste and also smell. But generally, it controls the pain, stretch, chemical changes, and also irritation in viscera.
Now I remember a little bit about the peripheral nervous system. For efferent neurons, it functions to transmit impulse from the CNS out to the peripheral organ to cause an effect or action. It also can be classified to two, which are the autonomic nervous system and the somatic nervous system. The difference between those two is that autonomic nervous system regulates the voluntary movements such as heart rate, digestion, which is performed without our conscious, while the somatic nervous system is about voluntary movements such as the movement of our leg, which is with our conscious. In addition, for autonomy, it is distinguished into two, which are sympathetic and parasympathetic. The sympathetic nervous system prepares the body for the fight and flight response during any potential danger, while the parasympathetic nervous system inhibits the body from overworking and restores the body to a calm state.
Yeah, that's true as well. When we are in danger, the sympathetic nervous system will cause our body to get ready for fight and flight action. For example, our heart will increase its rate and force, but for parasympathetic, our heart rate will decrease.
So when we walk, is it classified as autonomic or somatic nervous system?
It is somatic as we are able to control it with our conscious. Furthermore, I would like to tell you about the flow of this nervous system. It starts with receptors, then channeled to afferent PNS, then channeled to CNS, which will process the information. Then the information will be carried by the efferent neurons to the effector.
I see. Alright, you guys are amazing. Now I'm able to differentiate the differences between those two. The CNS consists of the brain and the spinal cord, while the PNS include all the nervous system tissue, including the sensory receptor, sensory neuron, and motor neuron. Without the PNS, the CNS will not have any sensory input to process, making it impossible for the body to react to the environment. And without the CNS, the information cannot be coordinated from the brain to different parts of the body, and make decisions about how we should react in a given situation. These two, which is CNS and PNS, work together in synchrony to create our conscious experience in our everyday life.
Don't we have any interesting things to do? Hey look, there is one television in library's technology room. Let's watch it together.
Ha 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 ha. I'm one step closer in completing my grand experiment.
Stop right there. You're under arrest. Your cruel experiment on animals has come to an end.
Drats! You've caught me! My plan is ruined!
Before we take you away, I have a few questions for you.
What do you want from me?
Explain now. Why are you doing these cruel experiments on the nervous system of different animals?
Well, it's simple really. By studying and conducting experiments on different animals, I'll be able to find a way to control these animals and have them under my control.
What about the jellyfishes and starfishes over there? Why did you throw them away?
Those animals, they are completely useless. These animals have no central nervous system. Cnidarians, or we call hydras, have a nerve net, which is a decentralized nervous system with no brain, no spinal cord, but a collection of nerves that extend out and help to regulate the body of the organism. While the echinoderms, the sea stars, only have a nerve ring. What use do they make to my experiments?
But that doesn't mean you should throw them just like that. I've noticed that you've also been experimenting on insects, huh? Insects are one of the animals with central nervous system, if I'm not mistaken. They have a brain, ventral nerve cord, and clusters of connected neurons called ganglia.
You are smarter than you appear, Inspector. And yes, you are correct. This ganglia controls the movements and behavior of the insect without input from the brain. However, you're missing out on the planarians and annelids, Inspector. Similar animals with central nervous system too. These planarians have a ladder-like central nervous system that consists of longitudinal nerve cords along the lateral side of the body and show cephalization with the brain at the anterior side.
Wait, so these planarians and annelids are those flatworms and leeches on the table?
Aha! Not so smart after all, Inspector. But you are correct. While I told you about those flatworms just now, these leeches have a brain and it has a nerve cord that extends down the center of its body. Each segmented ganglion is largely responsible for sensory and motor functions within the segment.
Be quiet and behave. Now, I've been going through your research notes and I stumbled onto something interesting. It seems that mollusks have well-centralized nervous system dominated by a large brain. Is this why I can spot a large amount of octopuses and cuttlefish in your lab?
Yes, they are my perfect lab rat in completing my grand experiment. That is, until you showed up. Those octopus and cuttlefish have the highest brain-to-body mass ratio of all invertebrates, even greater than that of many vertebrates, with their highly complex nervous system, only part of which is localized in its brain that is contained in a cartilaginous capsule. Do you know that 2/3 of an octopus neurons are found in the nerve cords of its arm? That is why they show a variety of complex reflex actions that persist even when they have no input from the brain.
But what about vertebrates like us? Our vertebrate nervous system is divided into a number of parts. The central nervous system includes the brain and spinal cord.
how do you actually compare us with other animals and even dare to imagine controlling any of these animals?
You forgot that we have a dorsal rather than a ventral nervous system, Inspector, and the existence of the peripheral nervous system. The peripheral nervous system consists of all body nerves with motor neurons pathways that are grouped into somatic, skeletal, and autonomic, which consists of smooth muscles, cardiac muscles, and glands. Then, these autonomic systems are subdivided into sympathetic and parasympathetic systems. With just a little bit more research, I could make use of our complex nervous system to link and control these animals, and no one will dare to stop me.
Well, it seems that this is not your day because you are going straight behind bars. All your research notes and experiments will be confiscated and shut down. We will not let you dare threaten the safety of our work.
Ah!
Thank you, and welcome to everyone's favorite game show, Nervous Trivia. Today's contestants have just entered our bonus round and are trying to win our grand prize, a $30,000 in cash and an all-expense 6 days vacation to Australia. Please welcome MUSFIRAH and FARZANA. The rules are simple. I ask a question, the first to buzz in answers. If the answer is correct, you get 5 points. If it's wrong, you lose 2 points. You have 3 lifelines throughout the game and can only be used once in each question. Are you ready? Are you ready? Are you ready? Okay. First question. What is neuron and its basic function? Yes, MUSFIRAH.
I got this. Neuron is the basic working unit of the brain and nervous system. It is an electrically excitable cell that process and transmit impulse through electrochemical signaling.
Super! Correct. Next question. What is the component of neuron?
Neurons contain dendrites, cell body, axon, and synaptic terminals.
Correct. 5 points for you, MUSFIRAH. Next question. Look at the diagram above. Okay. What type of neuron is that and why? Yes, FARZANA.
That would be sensory neuron.
Correct. And why is that your answer?
Because most of the sensory neurons are unipolar as the depiction shown. In addition, sensory neurons is used to transmit sensory information from receptors receptors of peripheral nervous system towards the central nervous system. Did I get it right?
Yes, correct. And bonus point for giving the function of sensory neurons. Next question. What are diagram A and B? Yes, MUSFIRAH.
I just forgot it. What is it just now?
Time's up. FARZANA, you may answer the question.
I'm not sure. Can I use a lifeline?
Yes, you may. The answer for diagram A begins with the letter M, and for diagram B, it begins with the letter I. Your answer, FARZANA?
Okay, I got it. Diagram A is motor neuron and diagram B is interneurons. Did I get it right?
Yes.
Oh my god, Farhana, you are so lucky because I almost got it just now.
And
Too
you're
bad.
correct, Farzana. Next question. What are the types of structural classification of neurons based on the number of processes coming off of the cell body?
Wait, I remember it's anosmic neuron, bipolar neuron, multipolar neuron, and pseudo-unipolar neuron.
Correct. Next question. What are the 4 major neuroglia in the central nervous system? Okay, yes, Farzana.
The 4 major neuroglia in the central nervous system is astrocytes, microglia, epidermal cells, oligodendrocytes. May I add my answer? In
Yes,
In the peripheral nervous system, there is Schwann cells, also known as neuron lemocytes, and the satellite cells.
Correct. And bonus point for the extra answer. Next question. Myelin sheath formed by the neurolemocytes wrap around the blank of a neuron to provide protection and insulation. A. Axon. B. Soma. C. Dendrite. Yes, Farzana.
I want to use my lifeline.
Your clue is it carries nerve impulses away from the cell body.
Okay. Axon is wrapped with myelin sheath formed by neurolemocytes to receive protection and insulation.
Correct. Next question. Structural and metabolic support for neuronal cell bodies is the function of blank. Yes, MUSFIRAH.
That would be satellite cells.
Correct. 5 points to MUSFIRAH. Next question is based on the pictures above, myelin increases the speed of action potential. What is the cell that produces myelin sheath? A. Neuron. B. Oligodendrocyte. C. Microglia. And D. Gray matter. Yes, MUSFIRAH.
Can I use a lifeline?
Yes, you may. The answer rhymes with website.
Oh, it's B, oligodendrocytes.
Correct. Next question. Microglial is involved in myelin production and electrical insulation. True or false? Yes, Farzana.
Lifeline, please.
Your clue is microglial is a knight in shining armor. Your answer, Farzana?
False. Microglia is involved in defense and immune-related activities.
Correct. Next question. Schwann cells surround all axons of neurons in the PNS, creating a neurolema around them. Neurolema allows for potential regeneration of damaged axons. Another function of Schwann cell is A. Creates myelin sheath around most axons of peripheral nervous system. B. Transmit motor information. C. Receives incoming signals from other neurons. Or D. Control voluntary muscle. Okay, Farzana?
The answer is A. Schwann cells creates myelin sheaths around most axons of peripheral nervous system.
Correct! Next question. Astrocytes create a supportive framework for neurons. It monitors and regulates interstitial fluids surrounding neurons. True or false? Yes, MUSFIRAH.
True. In addition, astrocytes also secretes chemicals for embryological neuron formation and stimulates the formation of scar tissue secondary to central nervous system injury.
Ding ding ding, correct! And bonus point for the extra answer. And now we will enter the speed bonus round. In 1 minute, those who answered the questions correctly the most wins. All of the questions are true or false. If false, you must make the statement true by giving the correct information. If not, you go home with our consolation prize, a fine set of encyclopedia on nervous system. Remember, first to buzz answers. Are you ready?
Yes.
I'm ready.
First question. Interneurons transmit information between neurons within the central nervous system. It analyzes inputs and coordinates outputs. True or false? Yes, Farzana.
True.
Correct. Next question. Sensory neurons transmit motor information from the CNS to effectors. True or false? Yes, Farzana?
False. Sensory neurons transmit sensory information from receptors of peripheral nervous systems towards the central nervous systems.
Super! Third question. Motor neurons transmit motor information from the CNS to effectors. True or false?
True.
Correct! Next question. Ependymal cell aid in production and movement of cerebrospinal fluid, CSF, involved in absorption. True or false?
True.
Yes. True, correct. Next question. Oh, that means time is up. And Farzana has the most points. Congratulations. Pack your bags and we'll pack your wallet. You're off to Australia. Well, that's all for today's show. See you next time.
Hello and welcome to the Daily News. My name is Ain. Our latest shocking news today is about alcohol addiction involving the famous mad scientist. The mad scientist was reportedly lying on the side of the road in a drunken state and was sent to the hospital for further examination and tests. We are going to be investigating more, and shortly we will be going live with a nurse in charge in the hospital. So, what happened to the mad scientist?
After we did urine and blood tests to detect heavy consumption, we discovered that the mad scientist is actually an alcoholic.
Oh no! So what is the side effect of the alcohol on him? I bet people want to know more since he is a well-known scientist.
Excessive alcohol can do over harm as many illegal drugs. Alcohol also has an extreme effect on the complex structure of the brain. It blocks the chemical signal between brain cells called neuron by reducing the ability to transmit electrical impulses, which is essential for the brain, leading intoxication, impulse behavior, slow reflex, slur speech, and poor memory. Hence, it explains the mad scientist condition. But you can ask more about how alcohol disrupts the chemical signal between brain cells with our amazing neurologist, Dr. FARADILLA. Here she comes.
Okay, thank you, Ms. Fawaz. So here I am, Dr. FARADILLA. I want to explain how actually alcohol disrupts the chemical signal. Alcohol acts as a general depressant of the central nervous system. It depresses or inhibits the function of neurons by reducing their ability to transmit or fire electrical impulses. These electrical impulses carry information that is essential for the normal brain function. The overall inhibitory effect of alcohol on the brain is very similar to that produced by other drugs that cause sedation and anesthesia. Neurons communicate with each other through the transmission of electrical and chemical signals. Because electrical impulses cannot jump from one neuron to another neuron. Electrical impulses are converted to the chemical signals. The conversion of electrical to chemical signals occur at the synapse, the connection between the two neurons. The chemicals are called neurotransmitters. They diffuse across the synaptic space between neurons and bind to the specific protein or receptor on the receiving neuron. This binding direction triggers a new electrical impulses in the receiving cell, and the communication proceeds so that the brain can function normally. Last but not least, alcohol will inhibit the generation of the new electrical impulses.
Wow, thank you so much, Dr. Faradillah and listeners. That was very insightful and informative. Well, folks, that's all in the daily news. Have a nice day, everyone.